do like the last question?
Huh?
Will we do the last
No,
question?
6 questions I had given you guys. Most of you had solved it. There were some doubts about some questions. I randomly picked 5 out of them. If the teacher solves all the problems, what the students will solve. So I'm leaving some for you guys. And I did that on purpose because these were conceptual questions. There was nothing so difficult about the formulas or the concepts underneath. It was more to do with how you approach them, right? If you remember what we did yesterday, okay, no running on the road. Go slow. We did not. Yes, Vishal.
I wasn't here yesterday's class. What did we do yesterday?
So basically, we tried solving the assignments in the class, wherein I tried giving an approach for solving those problems. So most of you had solved them right, but some of you had some doubts around those probability questions. So that's what we tried solving, so that all of us have a simpler, easier approach towards solving it. Okay, so maybe I uploaded the video of the class without putting kind of the required sticker and those things on the video. So it is there on YouTube still, but not with the proper messaging. So once I do that, you guys can probably go through it once to see if there is something that was meaningful or useful for you. Okay.
Yes.
Alright, so as I keep saying, yes, we won.
Actually,
Okay, that's okay. So as I keep saying, right, maths is not that difficult a subject. It's just about doing that with a more disciplined or organized approach. So that is what will remain our tagline for this group, or for everybody who is learning math from me. Keep that in mind, that none of the math problems are supposed to be difficult unless you purposefully make it difficult. Sanvi is not in the class. Okay. Alright, so I'll keep getting everybody's attention back in the class if I see you guys are distracted. So yeah, sorry about that. So what are you going to learn today?
we can learn about trigonometry, like how to assign, like we can do
What?
like angles.
Keep it quiet.
Or like we can do
Keep it
ratios.
quiet there. When I asked what are you going to learn today, I had posted a message saying what we are going to learn.
Oh, I was thinking that.
Nobody's
I
paying
think
attention.
we can ask what we can learn.
No. I'm not going to ask. If I keep on asking you guys, then there'll be no structure to it.
What about me? I'm untouchable. I actually wanted to ask like a real life subject.
Happy? Right. Alright. So I had posted a message saying what we are going to learn today. Who knows, who has access to that information? Who knows what I mentioned?
Can I check it out right now?
No. Anybody? Okay. I have a simpler answer for that. So I had mentioned that we are going to learn about exponential growth and decay.
Exponential growth and
Decay.
wait. Exponential growth in what?
And decay.
Decay.
And or decrease, whatever you call it.
Oh,
Yeah? Exponential growth and decrease, let's say. Now, before I start teaching you guys, somebody from the screen, can you tell me what you mean by exponential growth? And hear me out clearly. I said somebody from the screen. Anybody? I mean, give me an English definition of exponential growth. That's fine. You're not on the screen, but still I'll let you talk.
what was the word again?
Exponential growth. What do you understand by exponential growth? Think about it before you raise hand.
Of the economy.
Don't go way too far.
With the increase of exponents?
Is it economy?
No.
Exponential.
No, don't relate that with election, economy, voting and all that, okay? I'm saying exponential growth. Exponential and growth.
Was it exponents?
Okay, something like the exponents.
Does it have to do with increasing the rates? Because it's an exponential growth.
Tell me the English thing, English meaning of it. Exponential growth.
Increasing.
Increasing, okay. Yeah, Vishal.
When a rate becomes like increasing, like in a like so like like a curve, like it becomes more and more in like in a rapid proportion, like some proportion.
Okay.
Like it increases in a certain pattern.
Okay. Yeah.
Like
Okay.
a parabola, the curve.
Okay. Maybe you are going way too far. You are assuming that your teacher is very intelligent, which is not the case. But yeah, I'll still take it. Okay. I'm trying to get a simpler definition of it. Okay. Let's see what Sanvi has to say. Yes, Sanvi.
Never mind.
No. I mean, you can still assume a teacher is intelligent, but I'm saying you can give a simpler definition.
Exponential growth means a quantity increases at a rate proportional to its current size.
Okay, I'll take it. Let's see what Myra has to say.
I think exponential like growth is when a rate constantly like it's progressively growing like at a rapid pace.
Okay, I'll still take it. Let's see what Pradeep has to say.
So I think exponential growth is like rapid growth of exponents.
Okay. Alright. So, if I kind of collate everything that you guys said, as I mentioned, I'm not very intelligent, but I could catch two words from what I heard. Rapid growth. That only got stuck with me. That when you're talking about exponential growth, you're talking about rapid growth, meaning it's growing very fast. Okay?
Oh.
Now, this was the English part of it, and this is not an English class, so we have to go back to maths. So let's do that. Now let's look at this. 2 becoming 3. Let's say I have $2. I put in a bank. Bank gives me $3.
Okay.
One after 1 year. And don't keep saying okay in between. Okay, it's here. That's more important. Next year it becomes 4. Then becomes 5. It becomes 6. Becomes 7. So after this many years, it becomes like this. Then think of another situation when 2 becomes 4, becomes 6, becomes 9, becomes 12, becomes 18, becomes 24. Here the growth is much more steady. Here it is little more fast. There is nothing for you to explain.
I need to ask a question.
No, you're not supposed to. Hold it.
Isn't it higher?
Hold it. See, if you keep on asking questions when somebody's trying to explain it, you're disrupting the chain of thought. And you're not paying attention to what has been told. Once you come to a logical point and then you ask questions, that will be more productive. If you keep, I said 2, I have a question. I said 3, you have a question. I said 4, you have a question. How far we can go? Nowhere. Control it. Okay? I'll come back to you. I'll make sure that I explain things to you, but without disturbing the class. So this is another situation. Now, look at this. I put a 2, becomes 6, becomes 9, becomes 16, becomes 64. Let's say 34. It doesn't go that fast. Then 66. Then 102.
More faster.
It's much more faster. So here there is growth. Here it is even steeper growth. Even much steeper growth. Yep.
It was a truck.
Truck is okay as long as the guy doesn't break anything of my house. Okay, so what you are seeing as a difference here is that this probably, if I go by what you guys told me, that exponential growth is a rapid growth. This probably could be a candidate of exponential growth. I still don't have a method to the madness. I just know that it's growing very fast. I don't have a mathematical definition of it, but just by looking at the relative growth here in all the 3 scenarios, I see this is probably more exponential in nature, more rapid in nature. That is how we have related the English definition with some mathematical representation. Now let me take your question. What was the question?
So when you put it at 6269, does it have to do with the input output table? So it keeps on.
So no. So not okay. My request to you would be take one thing at a time. If I say exponential growth, when Vishal was explaining that it's like a curve or a parabola, what did I do? I stopped him politely saying, no. You are assuming that your teacher is very intelligent, which is not the case. When you're learning concepts, don't try mixing too many things, because I know everybody knows a lot of stuff. But if you keep on mixing a lot of things in between, you will not get the crux of the concept first. Once you know the concept, and then you can try relating it. When you're halfway through, don't do that. That will get you distracted. Yes.
So exponential, how do you say it? Like exponential growth?
Exponential growth.
Is
Yeah.
technically
A rapid growth. Faster growth. Rapid growth. Yeah.
Which
So-
exponential means rapid?
Yeah. It means rapid. I mean, so far that's what we know, right? I mean, I have not gone to any formula which says. Now let's look at one situation. You have, let's say, $100. I hope everybody is with me, right? So far, everybody is following me, correct? Okay. Let's say you have $100. You go to a bank. Bank says, you deposit this money with us. I'll give you $5 interest every year. What happens? After first year, your $100 becomes 105. Next year, bank gives you another $5 because you are keeping the money still with them. So it becomes 110, 115, 100. Or let me not put it this way. Let me put the bank at the bottom. You had $100. After 1 year, it became 105. After second year, it became 110. After third year, it became 115, 120. So yeah. Now, what the bank is doing, they are giving you $5 every year. But you know what? Bank is actually cheating you.
dang.
Why? You have kept $100 with them. After 1 year, your money has become 105. When they were giving $5 interest on 100, why did they not give you more on 105? Think of the situation after 10 years. Your money has become 150 now. Ideally speaking, they should have given you at least $7 after 1 year. Bank is just randomly giving you $5 after keeping your money with them for 1 year. Okay? After 1 year, your money has already changed by $5. It has become 105. So bank should give you more.
Oh.
Because your base money is different now. But it is still giving you $5. So here after third year, see, you have $150. This is your net worth.
So
But bank is still giving you $5, which was the case with the $100
so what you're
also.
saying is that pretend that you give $100 for you, and then they give you $5 every day.
Every year.
But if you have $105, they should give you more interest
Little more,
since it's
yeah.
more money.
Yeah.
Oh.
Yeah. But, so anyway, that is not the contention. Hold it. Don't get tempted to ask too many questions. Now, this is one static pattern, very simple, linear path. Every year $5 you are getting. Okay, your money is increasing by $5 every year. This is a very stable graph, straight line kind of. Now think of this. Bank says, I'll give you 10% as a compound interest. After first year it becomes 110. So $10 here. But they're saying 10%. That means for the second year, they'll give you 10% of this. So 10% of this will be $11. So it becomes 121. Next year it gives 10% of this. So 131 point something. And see how it is growing now.
That sounds fair.
That sounds better.
That is a faster growth.
Oh, more exponential.
Yeah. It is.
Unlike the 5.
Yeah, your base itself is changing. So you had a base, you got an interest, your base increased, then growth is happening on the top of that, then your base increases. This is where
Then you get more money.
your growth is not linear in nature. It is, instead of going this way, it starts going like a curve, and then it will keep on increasing also.
going all the way up to
Yeah.
lace and back down.
Yes. So this is just, I have just given you guys some basic example. Yes, Dikshita.
Isn't it supposed to be 120?
No, it will not be because it's a 10%, not $10. So 10% of 110. This is your interest amount. Your interest amount is $11. So your base principal was 110 and then you got $11 interest. So that became 121.
Then you get 10% of that.
Yeah?
Which is like 12.5.
Okay. Hold it there, hold it. So far we have not done anything. Your teacher is literally wasting your time.
Experimenting.
But what I'm purposefully doing is I'm trying to give you guys a sense of what is a linear growth, a more steady growth versus exponential growth. You have a question now. Yeah. So sometimes again, this is just based on my learning, right? I mean, I was a student myself before I became this old and a teacher and whatnot, right? So it's normal. People getting tempted to ask questions is very normal. But then my advice, my recommendation, my prescription to you would be that sometimes we jump the gun and ask the question. Do you think your teacher has come to the class without thinking about what he's going to teach? If he did, he's not the right teacher. Okay? So I have thought about what all I have to teach you guys, what all you might not be knowing, because I've gone through this same page so many decades ago. Right? So sometimes hold your question, let it come to a logical point, and then you'll probably get most of your questions answered. If there's still something remaining, your teacher is there. Okay? Alright. Now let's look at another mathematical form of it. Do you guys know what is simple interest versus compound interest?
Yeah.
I know the difference of formulas, but not the actual thing.
Okay, so I will not let Arav speak. I will not let him speak because he is non-compliant.
Why not?
What it means is you are not. I said, hear the question completely before you answer it. I said, do you guys know what is the meaning of, what is the difference between simple interest and compound interest? By the time I was done with simple interest, he had raised his hand. So he had not heard the question completely.
Because my dad told me this.
Okay.
So simple interest.
Okay, so does everybody know what is simple interest and what is compound interest?
1/2 of it.
No, sir.
Okay, no. Okay. Praneeth, you know it already? Okay. Vivan, do you know? No? Okay. So, okay. What is interest? I know you know it. That's what I'm asking you.
Wait, isn't it like the amount of money like you're gaining?
Uh-huh. Yeah. Sitting.
It's basically you're getting additional money
Yeah.
for by percentage,
Okay.
and it's also based on time.
Don't give me complete lecture. Keep it short. Okay, yeah. Yes, Pranav. What is your...
It's a percentage of like money that's growing every like year, day, or month.
Okay. Interest is something that I'm interested in. As a simple, normal human being. Let's say if I have $500 with me. What is my interest? 500 is my money. That is my principal amount. I'm not interested in that. I'm interested in figuring out who gives me money because of this money. Right? That is why it's called interest. That is where my interest is. I am trying to get more money for the money I have. I have, let's say, $500. One bank says, I'll give you 10 if you keep it with me for 1 month. Another bank says, I'll give you 25.
That's good.
What is more interesting for me? The one who gives me 25. That is what is called interest. So, simple interest is the extra money or the benefit you get out of your own value. Okay? So, in mathematical terms, it is, if you want to relate it with real life scenario, every bank, when you keep your money with the bank gives you a motivation to keep your money with them, and that is what is called interest. Some bank will say, I'll give you 5% interest, I'll give you 20% interest, I'll give you 10% interest. More the percentage, more the returns.
The more interest.
Hands down, hands down. So that is one thing. Second thing is, when we borrow money from somebody, they say, you have to pay me interest. Because that is the reason why they are giving us money.
Oh, okay. Oh,
When I bought this house, I had to take a loan, and the lender who was giving me the loan, he said, okay, I can give you for 3.5%. Less than that, not possible, go to somebody else. That is his interest. Now your question.
So does the interest depend on the time, like month or year, or what type?
That depends on the way it is defined.
okay.
Yeah.
What's a loan?
Loan is when you are borrowing. That loan, it was a question that was, what is loan? That was not a trigger for dance. You started dancing. Loan, No, you don't need to do that.
It's crazy.
Keep it calm. Keep it under control. It's a math class. It's not a, what is that called? What do you do?
Happy?
No, you guys do cheerleaders, right? Somebody is hitting a 6 and then everybody start dancing. There's nothing for you to dance. That guy is hitting a 6, that's it. Okay, anyways, coming back to the point. So, interest is as simple as, it's a money given to somebody by the lender, or it's money given by the borrower to the lender. Meaning, when you are keeping your money with the bank becomes your borrower because you are giving the money, you are lending the money.
I give you my money and then you have to pay me back with more money.
Yeah, that is interest.
Okay.
So, simple terms, the borrower gives extra money to the lender. That is interest.
For borrowing.
Yeah. Now, simple interest, when you say, I will say simple interest of 10% every year. Meaning, if you are keeping $100 with me, I'll give you $10 every year. So after 1 year, I'll give you 110. If you are keeping 2 years, I'll give you 10 plus 10. If you keep it for 3 years, I'll give you 10 plus 10 plus 10, $30. This is called simple interest. Meaning, when there is no interest given on the accumulated amount, it's given on the principal amount.
Isn't
Wait.
there also some formulas to find that?
I'll come to that. I'll come to that. First,
Wait,
understand the concept.
so-
why are you jumping to the
Wait,
formula?
could you say that again? Like,
You have, let's say you have $100 with you. You said, okay, I want to keep your. You have $100. You said, okay, I want to give you $100 if you want, but you have to give me $10 every year. That is my interest.
okay.
10%.
Alright.
So that means if I'm keeping your money with me for 1 year, I'll give you 110. If I'm keeping it for 2 years, I'll give you 10 for this year and 10 for next year also.
Okay.
Hands down. You are either dancing or you are disturbing. There are 2 D's, which I don't like.
Which is basically the same thing too.
So, if you are keeping it for 3 years, you will get me
$30.
$30. So this is a simple interest. I say, okay, 10% of whatever you are giving me is what I'll give you. Simple calculation, simple interest to you every year.
Okay.
That's a good interest.
Not a good interest. So, this is simple interest. Now, there could be a second situation where you will say, okay, fine, you can keep my money with you for n number of years. But every year, instead of you giving me the interest, make that your principal. So, after first year, it becomes $110. And then you have to give 10% interest on the top of that. 10%. After second year, this becomes my principal amount. You give 10% interest on the top of that. Not 10% of this. 10% of this revised number.
So 10% of the
So-
principal and the interest.
Interest of that year.
Okay.
So when you are giving interest on the accumulated amount, that is when it is called compound interest.
So, okay.
So now let's look at the formula, and now you will see why I am trying to connect the dots. I have, let's say, principal amount P. After n years, or let's say after 1 year, this becomes P plus P into my interest is, let's say, R. This much. So this is the principal amount and this is the interest. Yeah? This becomes my new amount. After 2 years, it becomes P plus P into R by 100
Times 2.
22 times 2. After 3 years, it becomes into 3 into 4. Okay? This is how my simple interest is getting calculated. So my new amount, accumulated amount becomes P plus P by R to the power n. Meaning if I'm keeping for n years, not power n, into n into this. Okay? However, so this is my accumulated amount, my principal amount plus number of years multiplied by the interest per year, that's my total amount. Now, imagine when your accumulated amount is calculated as compound, then it becomes P into 1 plus R by 100
Oh yeah, I remember.
to the power n. Here, what it means is, every year this number is getting multiplied to this, and this is increasing at a faster pace. In this case, your money is growing like this. In this case, your money is growing like this. This is linear growth. This is exponential growth.
Because you're adding the principal,
Okay.
not timesing it.
Yes.
Okay.
Yep. Yeah, Dikshita. Let's see if I confused you. I'll come to you.
Is this like a formula?
Yeah, this is a formula. This is a formula for calculating compound interest, where P is your principal amount, meaning the money that you are keeping for increase, R is your rate of interest in percentage, and then N is the number of years.
Oh, I remember. Okay.
So okay, what was your question, Arif? Quickly.
So when if a bank gives you interest, right? So if they decide not to give you, is that illegal? Or do they have
Consult a lawyer, not a math teacher. Let's come to this. No, wait, just 1 second. My principal amount is P. After 1 year it becomes P plus P into R by 100. This is my interest. Next year this becomes my principal plus principal to R by 100
times 2?
into R by 100. So here, and we keep on going. So from this, it becomes P into 1 plus R by 100 to the power n. So I'm not trying to solve this thing, but as you can see, this part is common, okay? So here, if you see, this, you can take P common, 1 plus R by 100, plus here, P common 1 plus R by 100 into R by 100. Okay, so that means P into 1 plus, after 2 years what it became? This part is common in both of them. So P, so if you guys are getting confused, don't worry about it, okay? I am trying to prove something that you guys have to never prove. This part is 1 plus R by 100.
That's long.
Wow.
Okay, so that is how this formula becomes. See, we're talking about 2 years. This got multiplied 2 times. If you are talking about 1 year, it becomes P into 1 plus R by 100. If you are talking about n years, it becomes P into 1 plus R by 100 to the power n. So that is what I was trying to say. So this is the formula for,
Because
see,
of every year.
yeah, the formula for compound interest is P times 1 plus R by 100 to the power n, where P is the principal amount, R is the rate of interest, n is number of years. Yes. Yeah, Dikshita, you had a question still.
No, sir.
Okay? Yeah.
So like the book my dad gave me, it's a principle and what's it called? What was the thing that you
Time.
what was Oregon?
Time.
Is accumulated amount.
Yeah, what was Oregon? Interest.
Heart rate.
Yeah.
Heart
Isn't
rate.
And it gave like things that you could figure out like the rate and time. There's like also other.
Do we have to?
P is the principal amount, A is the accumulated amount, R is the rate of interest, N is the number of years. That's it.
Wait, and so would linear be simple, then exponential would be compound?
Mm-hmm.
Okay, I got it.
Yeah.
Is it A the total?
A is the total amount.
Okay, yeah. Account.
Okay. Alright, so far we started with understanding what is exponential growth and we went from simple interest to compound interest, there is no need to dance. So here, what I'm trying to show is when your amount of change has a power, that is when you have x to the power 3, what do we call it? This is called exponent.
Yeah.
When you look at your equation, when you have a power as an exponent,
It's bigger.
that is what defines or dictates the growth. And that is why it is called exponential growth. And that is why you relate that with something like a compound interest, where you see the growth being much faster.
That makes so much sense.
Yeah? So when you talk about exponential growth, now again English is so very important, which is not my stronghold though. But if you see exponential and exponents, they have something in common. If you're talking about x to the power 3, this is an exponent. This is the exponent here. This is depicting an exponent where this is a power. So whenever you're talking about exponential growth or exponential decrease, you're always talking about something which has a power more than one. Or what will become? If you have something like this, instead of power n, you have power minus 3. That means it's minus 3, meaning it is getting divided by a bigger number. It's going to decrease. So it's simple. X to the power 3 is what? Let's look at a graph. If you have to plot y equals to x to the power 3, when x is 1, y is 1. X is 2, y is 8. X is 3, y is 27. See, this is what it is. Now, if this becomes y equals x to the power minus 3, what does it mean? This is a negative power.
That's fine.
That means y equals 1 by x to the power 3.
That's fine.
Exponents, right? Do you guys remember?
Yeah.
No?
The 6
Yes, sir.
Yeah? So when you have a negative power, that means it comes below. Now you try plotting this one. When x is 1, y is 1. Fine. When x is 2, y is 1 by 8, meaning y is here. When x is 3, y is 1 by 27. It's here. See, it is going down. So, when you're talking about exponential growth, it's going up. When you're talking about exponential decrease, it's going down at a rapid pace.
Okay.
And that means how you can relate. When you have power as positive, it's growing. Positive grows, negative decreases.
Okay.
When you have power negative, this is
That's
decreasing.
sad.
That is how you can relate.
So it's a profit and a loss.
Now, moment of silence.
Happy.
Now, question to everybody on the screen. Tell me, what are the things I have done to get you guys confused? Anything that was confusing enough?
Yeah, I got one.
Vishal, Vasundhara, Sanvi, Tanu, Vivan, Pranav, Myra, Gitesh, Praneeth. Not confused?
What was the question again?
No, I was just asking that whatever we have discussed so far, how do we relate linear growth with exponential growth? How do we look at simple and compound interest, and how is compound interest more relatable to exponential growth? And then how this exponential growth and exponent are relatable. And then if the power is more, that is more exponentially growing. If power is negative, how it is depicting the decrease or exponential decrease. I was just asking, was there anything that was confusing for you guys? That was my question. No? Okay. Sanvi, you are thinking what to say to the teacher? No? Okay. Tanu, no doubts?
No.
Praneet,
No doubts.
it was one of the topics that you had shared with me. Yeah.
Yep.
So clear conceptually?
Yeah, sure.
So I would want you guys to do a lot of practice with these concepts, okay? Because it's easier said than done, okay? I mean, I can make you believe that this is very easy concept, don't worry about it. And you will start dancing. But when you solve the problem, that is when you will know whether you have a reason to dance or you have a reason to be concerned about. So make sure that you practice the sums, because when you practice, that's the only way you can make sure that your learning is up to mark, or there's an opportunity for you to chase your teacher down. Yeah? Alright. So no confusion, no doubt with exponential growth. Okay, let's
What about exponential decrease? It's a negative.
were you in the class or in the movie theater?
I think he's in a movie theater.
I was talking about this as exponential growth,
I know.
and I talked about this as a classic example of exponential decrease, because when your power is negative, that means it goes in your denominator.
But
Meaning,
see, what about when it's in the real life, like for interest?
you put your money in cryptocurrency, rely on AI, ML, you will see exponential decrease only. Yeah. ChatGPT, people who rely on ChatGPT for doing their assignments, they have problem in the making, and that is where you will see exponential decrease in your score. Yeah. I mean, I'm not trying to discourage you guys from using ChatGPT, but what I've seen is kids have started believing that okay, teachers are not needed. I can rely on ChatGPT for writing my essay, and I have heard about cases where they got rejected by the most obvious colleges also for
Because they know
stealing the concept from ChatGPT for writing their essays.
Because he
But
already
see,
wrote
see,
it.
what if I thought you just ChatGPT?
That's for his job. He's
can
done with college.
he can get accepted to Google.
Try once. You'll not get a second chance. That's the problem. See, once somebody gets blacklisted for lying in their essay, I'm not going to say that name on the screen in a public forum. But remember, there is one person whom I know through a very trusted sources that he got rejected by UT Dallas for lying in his essay and misusing ChatGPT.
An actual person?
Yeah.
Who is it?
He's not going to say the name.
Did you hear me clearly? I said I would not say the name on a public domain. This is going to go on YouTube where anybody and everybody can see. Why should I malign somebody's image in a public forum without a reason? Yep. All right. Gitesh, did you understand? Guys.
Yes.
Okay. All right. So let's do some sample questions to see how much we understood and how we are able to apply them. Time to grow up. Alright, so let's say we are talking about scenario where
You get money.
keep it quiet. For $100, somebody gives or keeping the money in the bank for 3 years gives $130 versus $125 versus $132. Find out which one is the case of exponential growth.
Can you read it once more?
Yeah. But not whatever it says.
By keeping the money, $100 in the bank for 3 years, one bank gives you $130, one bank gives you $125, and one bank gives you $142. Which one is the case of exponential growth? And give me a mathematical reasoning, and that you're not going to give by just by raising your hand. Do your
Is it 142 or 1?
142.
Oh, okay.
And is that 145? Or that 128?
Is the second one 125?
Second one is 125, third one is 142. And I'm not just asking, see, anybody being blind-sighted also can tell me that 142 is the case of exponential growth. I want a mathematical reasoning, what percentage is applied and how it is
Can we
calculated.
just say like $10 or like do we have to say the percentage?
Percentage. Give me a mathematical reasoning. The question is, if you have $100, if you keep in the bank for 3 years, there are 3 bank options that you have. One bank offers you $130 after 3 years. One bank offers you $125 after 3 years. And the third bank offers you $142 after 3 years. You have to tell which one is the example of exponential growth and give a mathematical reasoning. Yes, Sadhvi, you were saying something.
Crazy.
Crazy?
This is crazy.
Who is crazy? Teacher or the question? Or both?
Question. Chat. Actually, no. Chat AI. No, this.
Yeah, Pranav.
I love chat.
Yes, Sadhvi, go ahead.
It was by accident, sir.
Not a problem. I was just pulling your leg. Yeah, yes, Sadhvi. I'll come to you, but just let her finish. Yeah, yes, Sadhvi, go ahead.
I think it's 125 because if you subtract 100 from everything else, the other two numbers are divisible by 3 since it's in 3 years. That means they're all growing at a steady rate except for 125.
Okay, that is one reasoning. I will take that as a parking note. Let's see what else I get to hear.
I think it's 142 because if you think about it, I did like the division and the multiplication and I
Are we
get
doing?
a 7 point.
I'll come to you, Vishal. Just give me 10 seconds.
7% increase.
How much you said?
About 7%.
7%. 100 becomes 107. 107. 7% would be something like maybe $9. It becomes 116, and then 7% will probably be around $10. Becomes 126. Doesn't go to 142. Think about it one more time. Yeah, Vishal.
Are we trying to find out about like which one is not an exponential or which one is?
Which one is exponential? And give a give a more convincing mathematical reasoning saying that no, this is 12% year increase as a compound interest, that is how it is. So I want you to kind of give that mathematical reasoning. Yeah, Myra.
So I'll go 125 because a lot of them is fancy actually because all the other numbers are perfectly divisible by 3 while 125 is not. Like when you subtract 100 from 125 is 25 and 25 is not divisible by 3 at all. So I agree with him.
Yes and no. I'm not denying that the thought process, but there is an opportunity for finding it for sure. Okay. Well, I'll come to that. Let's go to Deekshita.
What is R in the formula?
R is the rate of interest.
Okay, sir.
Is in principle the starting amount?
100 is the starting amount. Yeah.
Yeah.
Principal is the starting amount. Yeah.
I think it's the middle one because if you think about it, 100 times 100, so basically you're getting more money because see, after that, if you get more money from increasing, then now means that you get more money until you get.
You cannot give me a wrong reason to be convinced.
That's not wrong, actually, my calculation.
No, that is. You think about it and tell me one more time. I'll tell you why I'm not getting convinced.
I think it's 125 because it grows at like a rapid pace, like around 7.5.
But then 140 is much more than 125. Isn't it going faster than that?
Oh.
I'm not making sound. What happened? Everybody else is quiet. Give me a reasoning. See, I'm not asking you guys to solve it, but I certainly want to hear your approach. Now, let's look at it this way. You guys have to stop playing and stop drawing for no reason. You can show your skill in the right place. In a science class, if you do drawing, you might get a score that okay, you might be able to draw. Math class, you do it. US history class, if you start writing maths, nobody will appreciate that. Don't do it.
What if it's science?
That's a waste of time as well.
Density.
Don't do it. Don't stretch a discussion which has no future to it. Now, whatever I heard from Sanvi and Myra, okay, I mean just because we have just 10 more minutes left, so I'm just trying to be cognizant of the time. Whatever we heard from Sanvi and Myra, that was one way of looking at it, but I'm not liking it because I don't know why. If I have to keep on repeating myself for wrong reasons, I'm sure nobody is liking here in the class. And think of the kids on the screen, they must be thinking about who is this guy. I'm sure they want to see your face. Say, who is this guy who is disturbing the class every day? Don't be known for wrong reasons. That's called, there's a difference between being famous and notorious.
What does notorious mean?
There's a difference between famous and notorious. Find it out by yourself. You all have access to Google. Search it in Google. It will tell you.
Isn't notorious being like popular for a bad reason?
Exactly.
Oh.
It's opposite of. It's literally opposite of famous.
Like Adolf Hitler.
Going in the wrong direction again. Anyways, park it there. Now, we are talking about. See, look at the approach part of it. 100 to 130. It looks pretty straightforward. $30 given 3 years looks like a $10 increase every year. I'll probably skip that one for now. 100 to 125. If I'm rolling out 130, this is less than that. So I'll probably park this one also. Let's go to this one. Let's look at this. This is increasing by how much? 42. And I will not go with a flat calculation of 42 in 3 years. So 42 divided by 3. No, I'll not go by that. Let's see. Let's look at some rough calculation here. If I have $100, after 1 year it becomes 110. After second year, my 110 is the principal, and then I get $11 as a interest. So that becomes 121, approximately 121. And then third year, my interest is 121 plus 12.1. This becomes 132.1 or something like that. So this question was not, I kind of rushed through the calculation. I gave 142. I could have given 132. But the approach that I wanted to hear from you guys is not by doing flat division. Always look at, see, I said 132. Fine. This is not matching. Maybe this is matching. If I look at so it's not 10%, less than 10%. How about 9%? 100 becomes 109 after 1 year. 109
About
plus 10.9 or 11. It becomes 120.9. Okay? 119.9 after second year. And then add another 119.9 plus 11.9, somewhere close to 131 or 130. So you would not look at this being exponential, not being exponential by dividing the difference by 3. You would look at what is the approximate percentage which gets closer to this one. That would be approach. Yeah.
In the bottom one, when you're doing the 142, how did you know to add how did you know to add 11 to 110?
So I am saying it's if it is 10%.
Oh, 10% of 110. Oh, I get it. Yeah, then it's 11.
or if I go with 12%, maybe it might get close to this one. So again, this question might not be right. What I'm trying to assess here is the approach part. Never look at the difference to derive it's 1/3 and it is yes or no. Your approach would be which one is close. I mean, you will not get numbers like this. They will probably give you a percentage and say which one is closer to that. Is it applying simple interest or is it applying compound interest? So you will fit the formula and see which one is closer to that. That would be your approach. Yes, Dikshita.
It's not 132.1. It's 133.1.
133.1. Yeah, correct. So yeah, basically, what I'm trying to say here is when you are in a situation where you have to do comparison between simple and compound interest, you will not look at the difference and divide to find out your answer. You would always look at how you are deriving the simple interest versus the compound interest and see which one is closer to the desired percentage split. Okay, so that is what I was trying to say. Question might not be relevant. Approach is what I was wanting to hear from you guys. Yeah.
But in like an actual test, they would give you the rate instead.
They'll give you the rate or they will give you the number of years. So you have to predict the formula and see which one is closer. I mean, you don't have to go for a wild geese chase.
Yeah.
Like this, right? So
which answer was correct?
there was no answer. The question itself was not correct, really. I was trying to get the approach from you guys. So when you're talking about exponential growth, how you look at it versus what is the linear growth and what is exponential decrease. Let's try solving few sums. I will send you guys some assignments. I will let you guys solve related questions. Maybe I chose questions which were not related to what you will be asked. So let me send you guys some related questions, and then once you try solving it, then you would know whether whatever we learned in the class was relevant or not, or if there's something missing that we need to learn further. Okay? And Praneet, to you also, I would want you guys to send some questions to me. Anything that is not clear, and not only for Praneet, for all of you, right? So when we are learning about exponential growth and decrease, when you are trying to solve some problems, if you get stuck somewhere, let me know. We'll try solving it, and then I will any which way send you guys the assignment, which will give you an opportunity to practice. Yeah. All right. So that is all for today. Enjoy the rest of your weekend. Fun begins from Tuesday. You guys are off on Monday?
Yeah.
Alright.
I have school on Monday.
Okay.
I
So,
yeah.
all of you who have school on Monday, have fun. Whoever has no school on Monday, they also need to have fun.
Melissa.
Oh.
See you guys. Yep.
Bye.
Alright. Take care. Bye bye.
Alright, bye.
Bye. Bye.
Bye bye.
Yes, sir. Bye, sir.
Bye bye.
Teacher,
Mhm.
you speak